Good afternoon, all. We will be discussing the MCBs used in various three-phase local MCBs, testing procedure, and its resetting procedure. What is an MCB? MCB is a miniature circuit breaker. It can be opened by manually or automatically. MCB monitors the current continuously. It will monitor the current. It will trip if there are any overcurrent or short circuit. MCB will protect the industrial equipment for fire and safety things. Uh, Previously, instead of MCB, we are using fuses. Why we go for MCB? Actually, the resettable convenience. It can be resettable easily. Fuse, it will take some time, and it will be properly proper wire gauge to be used to reset the fuse. And if the MCB trips, once we identify the fault, we can just attend the fault and reset, flip the MCB to on. That's it. The and the MCB is more faster than the fuses, and the easy is troubleshooting. Normally, the MCBs and fuses are kept in a cubicle or different circuits. So we can easily identify by looking to the MCB box or that the panel which part of the circuit is having problem. That MCB will be tripped condition. And safer design. The MCB can be reset by anyone, but the fuse can be reset. We need an expert, technical expert. The type of MCB that we are using in three-phase locomotive, according to the poles. This one is single pole MCB. This one is having three-pole MCB. Single pole MCB normally used in single phase supplies like blowers, heaters, and the three-pole MCB we are using in motors, compressor, etc. Different types of MCBs. Actually, according to the characteristics, the MCB is classified type B, type C, and type D. The type B MCB is purely used in resistive loads. If the load is resistive, like household wiring and small circuits, we are using type B MCB. In type C MCB is used for inductive loads. Inductive loads means motors, blowers, etc. Type D MCB we are using in inductive loads with a high interest current. That means the compressor, X-ray machines, etc. Circuit breakers provided in HB1 panel. Actually, we have so many MCBs in HB1 panel and HB2 panel. It's almost same. In these MCBs, only 47.1 bar 1 is used for compressor is having D curve MCB or type D type MCB. All the others is C curve MCB. Just for reference, I quote this. All the other MCBs are of C curve. The MCB used in main compressor, it is D curve. This is the internal diagram of an MCB. Here in the top portion, we are having a cable terminal. This is fixed contact. This one is moving contact. Here is the operating handle. This is a coil assembly. I will explain the function of the coil assembly later. And this is the arc chamber. Actually, the MCB is intended to operate in load condition. So when the MCB is operating in load condition, the arc will be formed. So to extinguish the arc, there is an arc chamber. It is like an arc chute. This is the mounting rail. This is the cable terminal, top portion and bottom portion. The important portion of this MCB is a bimetallic strip. I will explain it in detail. Type of MCB tripping. Actually, if the MCB trips, there might be two types. There may be two reasons. It will be thermal tripping or magnetic tripping. It is having two mechanisms to trip the MCB. Once the MCB will get tripped, it may be due to thermal tripping or magnetic tripping. We will go detail. What is thermal tripping? Actually, for thermal tripping, MCB provide the thermal tripping. The MCB will trip due to overload. Overload means if the MCB is intended to operate in 10 amps. See, the load is taking 10 to 12 or 13 amps. It is called overload. It will eventually trip the MCB. For this thing, we are using a bimetallic strip inside the MCB. This is the bimetallic strip. Actually, a bimetallic strip is a this one is the bimetallic strip. Two dissimilar metals is sandwiched one over another. So what happens if the normal condition in at normal current the MCB will work normally, but if there is an overcurrent, the current through the MCB is passed through this bimetallic strip. Due to the overcurrent, the bimetallic strip gets heated. So if it is made of two dissimilar metals, the expansion of these bimetallic strip will be different. So it tends to bend. So by bending this, it will trigger the trip mechanism and eventually trip the MCB. This is the animated view of the bimetallic strip or thermal tripping mechanism. This is the bimetallic strip. These are two dissimilar metals. At normal condition, this will not get heat up. So normal current is passing through. Once the current is increased, it will generate heat and the bimetallic strip tends to bend. So once it is get bent and it will trigger, so MCB get open. This is the internal normal parts inside the MCB for bimetallic strips by the thermal tripping. This is the bimetallic strip. This is the connecting rod, and this one is the casing. Just for next thing is magnetic tripping. Magnetic tripping means once the MCB is having a short circuit. For short circuit protection, this magnetic tripping occurs. Actually, at that time the MCB will trip without any at same instant. So it will trip in 0.1 second to 0.01 second. So for magnetic tripping, there is an electromagnetic magnet situated in the MCB. So normal time, the magnetic field created by the electromagnet will be less because normal current is flowing. If the current is excess due to short circuit, the magnetic field created by the electromagnet will push the trip rod and the MCB will be tripped. This is the electromagnet coil. Inside there is a plunger is there. Normal current, the magnetic field will be very less. So it will not trip. At high current, the magnetic field created by the electromagnet inside this MCB will be high. So it will eventually pull the tripping mechanism. The thing is that for short circuit, the MCB will trip with no time. This will help in short circuit to prevent short circuit. Normal current it will not trip because the normal current will the magnetic field created by the electromagnet is directly proportional to the current through the coil. This is the parts of magnetic tripping MCB. MCB's parts. Actually, main part is the magnetic element inside that. This is a dismantled thing. Actually, this is the tripping curve for MCB. It is designed as per the IEC standard 60947 bar 2. This is a graph. How the MCB will trip and how much time it will take to trip. This graph is plotted in logarithmic scale. It is not in linear scale. Actually, this bottom of the scale, the middle point of this scale is 10. We will in linear scale there will be 20, but it is in logarithm scale. It is in 1000. the actually for we are using the logarithm scale to reduce to accumulate more data in a smaller space. In y-axis, this time is plotted. In x-axis, the current, the multiples of current is plotted. Actually, uh, so if we are taking an MCB of 10 amps, if we are taking an MCB of 10 amps and the current passing through the MCB is 30 amps, the multiplication factor will be 30 by 10, 3. So this is 1, this is 2, this is 3. So it will take how much time does it take to trip? I will show. This is when we apply 3 times current, it will it will trip within. This one is 2, this one is 1, this is 2, this is 2.5, this one is 10, this one is 20, or this is 25. Almost 22.5 to 25 seconds it will trip. This portion is for thermal tripping region. The all the MCBs is thermal tripping is almost same, but the magnetic tripping will different B and C and D. The magnetic tripping means this is for intended for short circuit tripping. So B curve MCB will trip very fast. C curve MCB will trip. It will take more multiples of current. It can accumulate more multiples of current. And D curve MCB, it will take 10 to 20 times of this normal rated current. IEC tripping characteristics of MCB. Actually, we are following 60947 bar 2 International Electrical Commission standard for industrial application. For household application 60898. After this 60947 bar 2, the thermal tripping time. Actually, we both these trippings we will measure in the section. Normally, if we apply 1.05 into normal rated current, I will explain with an example. If the MCB is having 100 amps rating, we are giving a current approximate 1.05, 5% of extra. So 105 amps. It will not trip within 1 hour. This is the one testing procedure we are following. Another one, same 100 amps MCB, we are giving extra 30 amps. So 130 amps will give through the MCB. It will trip within 1 hour. These are the tests we are doing in our section to for thermal tripping. Another one is magnetic tripping. For C curve MCB, we will give 5 times current. For this case, it will be 500 amps. For D curve, it will be 1000 amps. So it will trip within 0.01 to 1 second in magnetic tripping. Short circuit tripping, will not trip within 1 hour. This one. For 1.3 times, it will trip within 1 hour. This is the test data we have tested for different locomotives, different MCBs. All these MCBs having 63 amps. So we have applied 3 times current, 189 amps. It takes 7.8 seconds to trip. It also withstands this 1 hour test. Actually, we have given 66.15 amps. It will not show tripping within 1 hour. And we give 81 amps for 1.3 times. It tripped 45 minutes. Likewise, all these MCB tested in the test bed. This is the resetting procedure for MCB. normal MCBs. Actually, when the MCB trip due to thermal reason or magnetic reason, or overload or short circuit, it will not go to the bottom portion. It will be stuck in the middle portion. So if we need to reset the MCB, we need to push the MCB to the bottom portion and gently put it back. Then we can click, hear a click sound. Then the MCB will be successfully resetted. Actually, we are having these MCCBs in our HP panel for oil pump converter 63.1. This makes some confusion. Actually, different models are having different color. Sometimes it is red color for red, black, white, and green. So for tripping the MCB, we have to push the plunger, the red button for tripping. We need to use the red button, red plunger. For resetting or again turn it on, we can use either green, white, or black. This is for different types. Okay, thank you.